Okay, welcome back everyone. In this video we're going to be talking about centripetal force. We'll talk about a brief definition and then we'll look at an example. So centripetal force is used to describe an object moving in uniform circular motion. And you might recall that if we have something going in a circle, that at any time its velocity is tangent to the circular path, and the acceleration is perpendicular, or points towards the center. Now we know from Newton's second law that F net equals ma, and that's true in circular motion as well. And what we say is that there is a net centripetal force that is equal to a centripetal acceleration. Now it could be the case that there's only one force, which is centripetal, or there could be several. And so we'll look at lots of examples, but for now let's look at how to calculate this. Remember that the centripetal acceleration is also equal to v squared over r. And we're going to get rid of the vector signs and just talk about magnitudes. So this is the magnitude of the centripetal force, mv squared over r. And before we look at an example, here's a couple things to keep in mind. First of all, this centripetal force is perpendicular to the velocity. Okay? In other words, if you think about gravity, the Earth going around the Sun, if this is the Earth right here, and we have the Sun in the middle, okay, the angle between the way the Earth is moving and the force is always 90 degrees. And so the force goes the same direction as the centripetal acceleration. And so what this means is that the work done by a centripetal force most of the time is zero. And believe it or not, this even applies to things like friction. Because if you're going in a complete circle, then the work is zero for a complete loop. That's a horrible circle. Okay. So what is a centripetal force? We've talked about how to calculate it, but what is it? Well, really, it's any force and it could be multiple forces, any force or forces that cause centripetal motion. Seems kind of an easy cop-out answer, but that's what it is. A centripetal force is any force that causes centripetal motion. And so there's lots of examples of centripetal forces. We could have gravity. Gravity is the centripetal force that makes the Earth go around the Sun, the Moon go around the Earth, and so on and so forth. And we're just talking about circular orbits. We'll get to elliptical a little bit later. So gravity, you could have a force of magnetism, and we'll talk about that a little bit later, a magnetic force, which could be centripetal. You could have tension, whirling a ball on a string. You could have friction. Okay, think about how race cars go around a corner. That's all friction. Well, it's also a little bit of the normal force. And we'll talk about how all of these could be centripetal forces. And as a very quick example, let's say that we have something going in part of a circular path and it's got a speed of 50 meters per second. The circular path is 25 meters in radius and the mass is 20 kilograms. Okay, so what's the centripetal force? Well, it could be friction, but the amount of the centripetal force is simply m v squared over r. And so we just plug everything in. 20 kilograms, 50 meters per second squared over 25 meters. And notice that what we'll get here is going to be 20, and then we have 2,500 divided by 25, so that's just 100, and I think that turns out to be about 2,000 newtons. Okay, now it's very important that you have kilograms and meters per second and meters. Otherwise, you're not going to get newtons. Okay, so next time we'll look at a few more complicated examples.